We'll be looking now at linear equations and how to solve them. These are equations of the following form. We have y equals ax plus b. You may have recall seeing this before. These can also be thought of as order 1 polynomials. So the general plot for something like this on the xy plane is a line. In this case, the slope is equal to a, and this point here is equal to b. So our goal is to do algebraic equations with this, which is to say, to compute values of x given y and values of y given x. This is a very standard algebraic technique and will be an important building block as we move forward. So we're going to review some of the essential tools you'll need to master for the CLEP and for more advanced mathematics to follow. So let's look at a few examples. One thing that can be important is to put things into what's called slope-intercept form. You may have seen this as y equals, say, mx plus b, but we can also call it y equals ax plus b. So let's look at an example. We have 3y minus 4x plus 7 equals 2y plus 8x plus 1. Right now I have y's and x's on both sides. So I need to do some rearranging to get it to look like y equals mx plus b or y equals ax plus b. So let's put all the y's on one side. So I have 3y minus 2y. And then I'll put all the x's on the other side, 8x plus 4x. And then I'll also put all the constants on one side. So I'll put this 7 over here as well. So plus 1 minus 7. So I took this over here and these over here. And now I just simplify. I have y equals 8 plus 4 is 12. And 1 minus 7 is minus 6. So this is the equation in slope-intercept form. Again, I have the slope here, the coefficient on x, and the intercept here. Let's look at another example of this. I have now 5x minus 6y minus 2 equals 12x plus y plus 2. And I want to put this into slope-intercept form. So I play the same game. I'll put all the y's on the left-hand side, all the x's, and all the constants on the right-hand side. So let's see here. That means I have minus 6y minus y. And then on the other side, I have my 12x minus 5x from sending this over, plus 2, and then I have the minus 2 here that I add. So I get this. So minus 7y equals 7x plus 4, and at the end we divide by minus 7. So y is equal to minus 1x, so just minus x, minus 4/7. So again, we put it into slope-intercept form, and we see that this sort of complicated-looking equation actually is just a simple line with slope minus 1 and intercept minus 4/7. We can also look at equations that are just going to ask us to solve for y in terms of x. Okay, so for example, solve for x when y is equal to 2. And we're looking at the equation y equals 3x minus 1. So in this case, I have a clear relationship between y and x. And now I just plug in 2 for y. And I have to algebraically solve for x. So I'll add 1 to both sides. 3 equals 3x. So x equals 3 divided by 3, which is 1. So I think this is a nice warm-up algebraic example. All we had to do was plug in 2 and then add 1 to both sides and divide by 3. And then we were in good shape. One more, slightly more complicated example. We can solve for x in a situation like this. 2x plus 3 equals 9x minus 11. And we'll use our rules of algebra again. So let's see, this is 2x minus 11x equals minus 11 minus 3. So minus 13x equals minus 14. Oops, this is, sorry, minus 9 there. So this is minus 11. So I get that x is equal to 14 divided by 11. So a nice algebraic exercise. We will now move on to systems of, or rather inequalities being governed by linear equations, which have very similar rules, but it's actually helpful, I think, even more than in this case, to plot the solutions. So we will be working on that in the next submodule.